Hello everyone, you are welcome to today's lesson. And in today's lesson, we have a simple task and it's going to be a very short one. And the task here is to look at the solution to the lesson 6 assignment on the topic functions. Okay, so just as you have on your screens, these were the questions. And remember, the lesson 6 had to do with finding the domain of what? Of functions. Okay, or finding the largest possible domain, okay, of what? Of functions. Okay, so please stick and stay with me. Okay, I'm Mr. Hackman, your usual facilitator, and take notes as I walk you through the solution. I will address, okay, most of your concerns, if not all, especially the major ones, okay, that came to bear from your various submissions. Okay, so without much ado, let's go and look at what the solution slide. Okay, as usual, so we've been told, I've told you that anytime you read questions, we are supposed to make it a habit to underline the salient parts. So here, let's read the question, find the largest possible domain of the following. So you are finding the domain. I've told you whether, okay, it's qualified by largest possible or not, we are still finding the domain. Okay, so after that, what do you do? The first thing that you write is solution. Okay, then again, you know, questions are numbered because we want you to also number your solution. So it means your solution must be numbered what? Forgive me, appropriately and what? And precisely. Okay, so in this case, this is what we have. I've told you any question after numbering, we extract the information, okay, whatever that we were asked to work on. So giving our h of x, but you can see that the h of x came, okay, in the mapping form. You cannot extract in what? In the mapping form, but you have to extract it in its relation, okay, form, corresponding relation form. And please, okay, I think I forgot to let you know that, okay, though I'm walking you through the solution, okay, this is the solution, okay, it also happens to be, okay, the marking scheme as well, because you can see marks allotted there, which is supposed to guide you do your marking. Okay, all right. So now we know you've been told that anytime this function that I'm giving here, okay, indirectly it's a numerator function. The denominator is 1. There is no denominator if I'm supposed to put it that way. Okay, and anytime you have a function, your numerator function, the restriction that you see there should be square roots. That is, your variable should be under a square root. But here, none of the variables here, okay, or yes, the variable here, okay, it's not under a square root. So whenever you have a numerator with no square root, then it means there is no restriction. So in that case, you draw your conclusion straight away. So it will be therefore the domain of h or h of x will be equal to x is such that x belongs to a set of real numbers. Okay, and you know domain must be a set, so you put it in curly brackets. So with this one, no restriction. So we know, I told you that for every domain, your conclusion will be the domain of the function is equal to, then you write this. If there are restrictions, you write comma and you attach the restriction. But here is the case, there is no restriction. So we didn't bring our comma and our restriction. There is no restriction. So after writing this, you end this. So meaning all, okay, real values of x, okay, will satisfy the what do you call it, the equation, the relation or the function that we have here, or will have what? An image, will make the function defined. Okay, so now we go to the next question, which is f. Okay, so f again, with this one, thankfully the function is given in the relation form, so you extract it as such. And that will give you, sorry, that will give us, well, if you extract b half. Okay, so now you can see that you have a numerator, your denominator is 1. Okay, however, you can see that the numerator has what? Okay, your quantity that you are taking square root of as x with it. So it means here there is restriction. Okay, so in that case, you cannot draw your conclusion straight away. You have to go and find the restriction, then later attach it to, okay, to the way that you were asked to conclude. That is this particular one. Okay, so now what do we do? Because we have restriction, you start by writing for the domain. And for the domain, okay, our radicand here, what you have under the square root, because what you have here is a numerator square root, okay, the inequality becomes greater than or equal to 0. So for this square root, okay, to give us a value, a real value, the 7x plus 9 should give us what? A number which is greater than or equal to what? 0. So at this point, you come and solve for what? Your x. So here, thankfully, your x term is positive. So you move this one to the side, and that will give you -9. You write it again before you divide. Then after that, you end up getting s is greater than or equal to -9 on 7. Okay, so at this point, what do you do? We are now going to have our conclusion. So domain of the function h will be equal to, okay, again, x is said that s belongs to a set of real numbers. This time around, we have restriction, and you attach your restriction. However, you know, when you are drawing your conclusion, you avoid concluding with an improper fraction unless otherwise stated. So in your conclusion, you are supposed to convert this one to its corresponding mixed numbers. So if you fail to convert to mixed numbers, okay, please take note. I've told you this one, I mean severally. So you will lose the entire marks here. Take notes. You will lose the conclusion marks. Okay, take note of that. All right. Okay, then now what do we have? We come to the next one, which is I. Okay, so I, what are we giving? We are giving this function. It came in the mapping form, so you extract in the relation form. If you extract in the mapping form, again, it will be B0. Okay, with this one too, if you extracted it in the mapping form, it is B0. I've told you. Mapping form, function, I mean, way of representing function. Okay, our solution must be devoid of that. So meaning you shouldn't see that in your solution. They are best seen in questions. Please take note. So if you come to the gene, you extract the function in the relation form, which is what we have there. So that will also attract B half. Then for the domain, again, with this one, okay, numerator and a denominator. By the numerator, you don't have square root, so it means the numerator is not restricted. Now the denominator, I've told you just by the virtue of the fact that you have x in the denominator of a fraction, it means, okay, your function or fraction is restricted. Okay, just by x. You don't have to see any other, okay, operation or any other symbol. Once you see x in the denominator, it is restricted. Your function is restricted. So in this case, because I have a denominator function, it means, and that function contains what? I mean x. Denominator, if it was just a constant with no variable, your denominator is not restricted. Once you see a variable there, it is restricted. The variable that your function depends on. So now your denominator function for the domain, we know that if there are no other symbol but x in the denominator, then it means our denominator function should not be equal to 0. So that is the condition. For the domain, your denominator function, which is 2s squared minus x minus 1, should not be equal to 0. Okay, so look at the marks there. You know how to mark. Okay, now. Then now what do we do? This is a quadratic, okay, inequality anyway, because it's not equal to. If it's not equal to, then it becomes an inequality. So what do you do? Now you know if this side is factorable, you factorize. So you solve it as if you are solving a quadratic equation. But on each step on the way, you have to make sure that the sign, okay, is not equal to. Okay, so this side you come and factorize, and you know you multiply 2 and 1 minus 1, that will give you -2. -2 factors of -2, that when you multiply you get -2, when you add you get -1, and that will give you -2 and +1. So that will help you break the middle term here into these two terms. So the factor pair will be -2 plus 1. So you use that one to break this one. Group the first two, factorize, that will give us last two, factorize, and that will give us this. So not equal to 0, not equal to 0. And after that, what do you have? Now, this side, okay, your factorization will be complete. So it will be 2s plus 1 into the whole of that, okay, in one bracket, then x minus 1 also in another bracket. Or x minus 1 in one bracket, then 2s plus 1 in another bracket. Multiplication is commutative. It doesn't really matter which one you bring first. Okay, so after that, you use the zero product rule to set each of the factors to 0. So 2s plus 1 should be equal to 0, or your second factor here, okay, so it should not be equal to 0 because the symbol there is should not be equal to 0. So if you use equal to 0, you are doomed. Please take notes. Okay, unless you are looking at the except situation. All right, so at this point, if you are able to set each of the factors to, okay, not to be equal to 0, just as you have here, then the whole of that will be m1. Okay, so then, okay, with this one, you can easily solve for x. So you move -1 to this side, and that will give us this. So that will give you a half for this one. Now, if you come here with this one, okay, when you move, you won't get your answer straight away. So if you move, you are going to get -1. You write it again before you divide. So that will give you, this step will give you m half. Then when you come and get your solve for x that you have here, you end up getting a half for that one too. Now the actual a, that's our conclusion, will be there for the domain of the function. The function is g, or you can still use g of x. That's dom of g will be equal to, you know, x is like that x belongs to a set of real numbers, all right, but x should not be equal to, you know, x should not be equal to minus half or 1. Okay, so that's what you have here. And your ability to write that will attract or give you, okay, 2 marks. Okay, then the last one, the L. What are we giving? We are giving this function which came also in the relation form. So you thank God you extract it as such. And if you extract B half, as for the first, the extraction marks, that we should all get it. Okay, those marks are low hanging marks that, okay, I mean, we should do everything possible to protect. Now, okay, numerator function, there is no restriction. Okay, you see x there, but for numerator functions to be restricted, okay, your x should be under a square root sign, under a radical sign. Otherwise, it is not restricted. Okay, now let's come to the denominator. The denominator, okay, first of all, you see x in the denominator. So obviously, even with no other symbol or, yes, operation, we should know that once x is in the denominator, okay, your function is restricted. Okay, your x is restricted. Now, again, not only that, we can also see square roots in the denominator, and square root, you have x under the square root. So s appears in the radical. So it means, okay, just as you were told in lesson 6, it means there is additional, okay, restriction. Please take note. Okay, so originally, if this, okay, was not there, if the square root was not there, then it would have been 3s plus 10 not equal to 0, because you say that your denominator should not be equal to 0. Now, once the square root comes in, then it introduces what? Inequality. Okay, remember I told you that when the square root is in the denominator, the inequality that will come in will be greater than, okay, strictly greater than with no equal to, because you know that the denominator cannot be equal to 0. So you don't bring what? The equal to 0. So in that case, that informed this decision. So for the domain, your radicand here, okay, should not, or should be greater than, or I mean should be greater than, really greater than, forgive me, 0. It cannot be equal to 0. So if immediately you bring equal to 0, you are doomed. Okay, please take notes. Immediately you write 3s plus 10 is greater than or equal to. Once you introduce the equal to, okay, you are done. Okay, please take notes. You are going to lose the entire math. So at this point too, okay, you come and solve this simple linear inequality just as you did here. Okay, so you solve, okay, you move this one to this side, which becomes minus 10. Write it again before you divide, okay, and you end up getting x to be greater than or equal to minus 10 on 3. However, in your conclusion, you cannot conclude with what? An improper fraction. So in my conclusion, I wrote therefore dom of what? The function is f is equal to s is such that s belongs to a set of real numbers. Then we come and attach our restriction. So the restriction, because this number is an improper fraction, remember you have to change it to what? Its corresponding, okay, means what? Numbers. And by so doing, this is what you get. You get minus 3 whole number 1 on 3. So that will also give you, okay, 1.5, okay, marks. So please take note. If you don't change it to these numbers, okay, please take note. Again, you will lose the entire marks here. Take note of that. I've told you, avoid concluding with an improper fraction unless otherwise stated. So in all, if you put all the marks here together, you are supposed to get 20 marks. So please take note. So indicate your score, okay, over the total score on top of your first page, okay, or below your last page. Please, okay, let it be boldly written, clearly written. And when you are capturing, okay, your marked version too, please make sure you capture so that your score over the total score will be visibly was seen. Please take note. Okay, so don't only write your score over the total score. So if you had 20, it will be 20 over 20. Don't just write 20. If you had 15, write 15 over 20. So I want to see the denominator, which will be your total, okay, marks, okay, the entire marks for, okay, this particular assignment. And your numerator will be your actual score. Okay, so on this note, I would want to say thank you very much, okay, for your time and attention. God continue to bless us.